Welcome to the Tech Ed Podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. New technology is the name of the game here at the International Manufacturing Technology Show. We are live in Chicago, Illinois, having just a wonderful time learning about all these new technologies, Industry 4.0, artificial intelligence, machine learning, robotics, automation. It is such a great time to be in the world of manufacturing, such a great time to be a student in the world of manufacturing, and that's what this week is all about. We're broadcasting from the Smart Choice Student Summit powered by AMT at Chicago's biggest convention center, and absolutely having a fascinating discussion right about now with the CEO of Clearpath Robotics. So this is a company that I got to know really well over the course of the last year and a half, doing really innovative things. They've got a phenomenal background, an incredible path to where this company started and where it has ended up. They have a brand called OTTO Motors we are also going to talk all about here on the Tech Ed Podcast. But with no further ado, it is my great pleasure to introduce to the audience of the Tech Ed Podcast, Matt Rendall, CEO of Clearpath Robotics. Matt, thanks for coming on.
Thanks for having me, Matt. Appreciate it.
So let's start here. Your brand is well known, I think, to folks in manufacturing, certainly well known to people that are adopting advanced manufacturing technologies and who understand the world of Industry 4.0. Maybe less so to some of the other folks that might be listening. So let's just start out really simple. Tell us, what is Clearpath Robotics all about?
Yeah, certainly. So Clearpath Robotics specializes in autonomous vehicle technology, but if you're familiar with autonomous vehicles, you probably have seen cars driving by themselves on public roads.
Yep.
We take that exact same concept, that exact same technology, and we apply it in the workplace, in industrial settings. And so Clearpath Robotics focuses on research and development of new industrial autonomous vehicles.
Okay.
And OTTO Motors is the application of that industrial autonomous technology into material handling. So that, it was probably 2013 when we started to realize, hey, this material handling space is going to be the first most vibrant application of autonomous technology that we could identify anyways. And so we started going pretty aggressive after it.
One of the things I was most impressed with as you and I got to know each other in Detroit, Michigan a few months ago was just your path to this company and what led you to founding the company. So tell that story, if you would, for our audience.
Yeah, certainly. So my co-founders and I met at the University of Waterloo up in Canada, and we were all studying mechatronics engineering.
Okay.
And in each our own ways found our way to the robotics club, just kind of looking for an interesting way to apply the learnings as fast as possible in a lab setting. And we would just tinker with robots till all hours of the night. We caught what is kind of known in our industry as the robot bug.
Okay.
Just became totally obsessed.
Yep.
And so when we weren't busy cramming for exams and doing the lab work and all that good stuff that everybody would be used to in an engineering education, we spent all of our free time building robots, traveling all across the country, competing in international competitions.
Cool.
And then it kind of came time to graduate, and at the time, autonomous technology really wasn't online anywhere.
Sure.
And so how do you get a job in your passion when it doesn't really exist yet? So really, the very simple idea that we had is, this is what we love, super passionate about autonomous vehicles. Mm-hmm. We would just love to figure out how to get paid doing what we love.
There you go. Yeah.
And so turns out the only way we could do that at that time just was start a company.
So you're transitioning from your education pathway into Clearpath Robotics. 2013, is that when it's about then? Or when was this?
So 2008 is when we got started.
Got it.
2013 is when we started OTTO Motors.
Okay, got it.
Research and development, or what would then become OTTO Motors in 2015. So 2008 is when we were graduating, but we were building robots together since about 2005.
Yeah, awesome. And so here you are 17 years later as a group starting out in college. Mechatronics engineering, by the way, a great field of study for any of our students who are listening and interested in, we're always interested in what pathways people take from education into industry. And what a perfect example of how, especially for maybe a young person who's fascinated by FIRST Robotics or VEX Robotics, and to hear a story like yours, which is, yes, this passion that you have for robotics, catching the robot bug, as you say, can carry into an incredible career and incredible technology. We're going to talk all about that today on the Tech Ed Podcast. We are here at the International Manufacturing Technology Show, 4 years since we've all been here in person. Have you been to the show before, by the way?
Yeah, I think the last one was, 2018?
2018, yep, exactly. So, and I was here in 2018, 2016. Then we had the hiatus, and we had IMTS Spark, I think they called it, 2 years ago, which was cool in its own way. But now to be back in person with everybody, seeing everybody, shaking hands, hugging, building relationships, it's just been great. And I know one of the things that everybody loves about IMTS is it's a place to come to see that latest and greatest cutting edge technology. What are some of the things, if they walk into OTTO Motors booth, or if they see some of your partners deploying your technology here at IMTS, what are they going to see that's new and exciting?
Oh, there's a bunch. I mean, a lot has changed in the 4 years since the last IMTS show.
Right.
Earlier in the year, we announced our autonomous forklift, which was always a priority product for us, but such an ambitious technical development at the same time. So we were developing our autonomous forklift for about 4 or 5 years before we felt ready to launch it as a product. So it's on display, jogging pallets back and forth and doing a relay handoff between our other OTTO 1500 autonomous vehicle. So yeah, the autonomous forklift definitely is worth checking out. We think we have a legitimate claim to the world's smartest forklift.
Wow.
And then on top of that, we've been investing a lot in software. So introducing new capabilities for our customers. An autonomous vehicle collects gigabytes and gigabytes of information per minute.
Wow.
It's a tremendous amount of data that these machines collect. How do you harness that data to unearth new insights for our customers about productivity or about how things are made that they can turn around and use to improve their operation? So a lot of the products that we've been developing after the autonomous forklift have been software modules that sit on top of it.
So speaking of innovation, one of the things that I've learned from you and your team, and I've learned so much, Matt, over the last year and a half or so, I'll be honest, when we started working together, I kind of lumped AMRs, autonomous mobile robots, automated guided vehicles, into one. It's just a thing that's moving material, right? And what I've learned from your team is that there are tremendous differences between those technologies. So for our audience members who are like me a year and a half, 2 years ago, and didn't really understand the distinction, tell us about the difference between an AMR and an AGV.
So first, let's just start with a very quick definition of an AGV.
Yep.
And before we even provide the definition of an AGV, let's go one layer back yet and give a quick definition or acknowledge a conveyor in the equation or the definition and the contrast.
Sure.
Right, so a conveyor is something that most people can picture pretty clearly in their head when you bring up the word, right?
You've got
linear flow, right? And that linear flow is tried, tested, proven. But once the conveyor is installed, can't really make changes too readily, right? And if a package gets jammed in the conveyor, the whole line goes down upstream from that, right? And so the AGV takes a lot of the underlying principles of a conveyor and captures them in a vehicle. So instead of rollers for a mile inside of your facility, you can instead have a vehicle that's following a magnetic line or an optical line, or even in the really early days, it was a chain underneath of the floor.
Sure.
But fundamentally, it still behaves like that conveyor. It is following a line, and if something gets jammed, everything behind it gets blocked up. An AMR removes the line, removes the track. And that, up until now, is something that really was a capability or a characteristic that only a human could bring to a delivery route. So the way I like to think about AMR is it takes all the really great benefits of an AGV in terms of predictability, repeatability, affordability, and it marries it with the intelligence and flexibility, adaptability of a human. And you combine those together and you have effective, low-cost, intelligent transportation in your operation. And so that's really the main difference. The vehicle can move off of the track. Another way that I like to just kind of round out the definition, if you think about any factory or warehouse, like a really busy city,
Right.
every busy city, in order to operate efficiently in moving people through the city, needs to have an effective metro system or subway.
Right.
Right? And the metro is great for bulk transport, low cost, right? Think about how many people you jam onto a subway and you're paying your $2 or $3 or whatever it is fare. But big cities also need taxi cabs in order to operate efficiently. You're paying a little bit more for a taxi,
Yep.
but you've got more efficient point-to-point transportation.
Sure.
And so I highlight that because for a city to operate efficiently, you need the subway and the taxi cab. And it's very common to talk about AGVs versus AMRs as if they're opposition. But I think they actually need to work in harmony inside of a factory.
Sure.
It's a very different part of the operation
Yep.
that they serve.
Yeah, mechatronics engineer with a mastery of the analogy. I love the way that you explain it. And in the same way, if I don't need the flexibility of a taxi cab, why not take the subway, right? If I'm just going point to point. So it doesn't necessarily replace the AGV. It's another application, another technology, and it just really comes back again to the business case of the use case and what is it that we're trying to accomplish, and then what is the best tool to be used in accomplishing that. But I really like the way you brought that down to the ground and explained it in a way that I think anybody can really wrap their brain around the differences between the two. One of the things that I've gotten really fascinated with regard to the OTTO Motors platform, and it's because of the business that we're in, which is education. And as you know, I spend a lot of time on the education side, not just on the Tech Ed podcast, educating folks and having guests who educate people about interesting things going on in manufacturing and technology and education, but also in bringing products to the world of education. And that's really where I got interested in your organization and the technology that you're utilizing. We see it as just a great way of teaching in the education space artificial intelligence and machine learning. And I went through a tremendous amount of the e-learning that's offered by OTTO Motors to learn about this technology. I did that toward the end of last year. The amount of, and you mentioned just the gigabytes of data that are being picked up every single second, every single minute is just being astounding. But the amount of artificial intelligence and machine learning technology that is buried onto the unit, and then of course in the cloud as well, it's really mind-boggling. So go in, and especially given your gift for making really complex terms and concepts simple, go into that a little bit for our audience. What is artificial intelligence and machine learning all about, and how are you leveraging that technology in the application?
The underlying technology in an autonomous vehicle, or one of the most prevalent ones anyways, is called SLAM, simultaneous localization and mapping. That really is the heart of being able to be a taxi cab as opposed to being a train. And so SLAM, first of all, to map is to, like if you think about Google Maps,
Sure.
right? There's a base data set that Google Maps is built upon.
Sure,
right? So
you bet.
You go into a factory and you need to construct a map because there isn't one. The best kind of frame of reference would be if you've seen like 2D floor plans or CAD drawings of a facility. That's a human-readable map. A robot needs to create a robot-readable map. That's the mapping piece of the equation.
Okay.
And so let's say now you already have a map, or it was given to you when you arrived. You need to figure out where you are in the map, and that's called localizing, right? So the "You are here" button, right?
Okay.
So an autonomous vehicle shows up into a facility. It doesn't know where it is, and it doesn't have a map. It needs to construct the map and at the same time figure out where it is, simultaneously localizing within a map that it's generating. SLAM. And not only do that at the first experience entering a facility, but continuously over the course of day-to-day operation. Because a facility, in many regards, is a living organism. It changes every single day. The work evolves. Even the continuous improvement initiatives that exist inside of busy facilities, minor tweaks and modifications
right.
on a shift-by-shift or day-by-day basis.
Yeah, that's how you drive performance in manufacturing.
Exactly. So that's part of what allows an AMR to intelligently respond to the dynamic nature of really busy factories or warehouses. So SLAM is a combination of algorithms where you're taking inputs from sensors. So the main sensors on an AMR are actually the same as the sensors on an AGV, safety-rated laser scanners. An AGV requires that in order to comply with safety. So there's a laser array that's projected around the perimeter of the vehicle, and it is, think of it like an invisible software bubble around the vehicle. And if anything gets into that bubble, the vehicle shuts down for safety.
Okay, got it.
That's one of the limitations of an AGV.
Okay.
It'll be driving down an aisleway, and there'll be a little piece of styrofoam or stretch wrapper that's just kind of fallen off of the rack, and it'll get inside of that little bubble. And so the vehicle will fault out, it'll flash some lights, it'll honk a horn, it'll wait for somebody to come address it.
Okay.
An AMR is able to see that, respond, move around it, but it's bringing in laser information, and we add cameras. So that's called the perception system. Like, you have a set of eyes, I have a set of eyes, and we rely on our eyes and our brain primarily to enter into a new environment, construct a map, and kind of figure out where we are. So this simultaneous localization and mapping concept is actually pretty human. So that's kind of the foundation layer of intelligence in the vehicle is all around how we handle SLAM. And every company approaches SLAM slightly differently. I think we have one of the most reliable, highest performance SLAM capabilities. I think that's one of the things that makes the auto AMR so prevalent in the emerging market. And so in response to your AI machine learning question, I would say SLAM is probably the big bucket to look at.
And when I learned about this when I went through some of the e-learning last year, and then we actually had an auto AMR at our tech center in Mequon, Wisconsin earlier this year, and actually watched it do in more of an office setting, because we're not a manufacturer, we're a distributor, and we watched it actually map the office, right? So you literally turn it on, somebody else was operating it. I'm sure there was more to it than that, but it comes on, they're interacting with the software, and all of a sudden it's driving itself around the office and figuring out what is a chair, what is a door, what's a table, learning this stuff on its own. And with a matter of, 10, 20 minutes maybe, give or take, it knew its way around the office and could operate just like a human being could, or in a manufacturing environment, just like a fork truck driver might, avoiding obstacles, something's in the way, finding another way around. In the same way, in the manufacturing companies that I owned, if somebody was driving a forklift and had to pick up a pallet of parts at a CNC machine and take it to the shipping dock, and there's another pallet of parts that somebody left in the middle of the aisle, it didn't pile right over the top of the parts, right? It realized it was there, that was the forklift driver, and would drive around, and the AMR is doing exactly the same thing using artificial intelligence and machine learning. So to me, it's just a great application, certainly for material handling in the manufacturing environment, but equally, at least in my mind, for teaching artificial intelligence and machine learning in an applied way in an educational setting. We're sitting here right now in the middle of the FANUC student experience, the Smart Force Student Summit. FANUC is a great partner of the Tech Ed podcast. You've got a great relationship with organizations like FANUC. Your technology doesn't necessarily operate on its own, right? You have to rely on integration and on working with other great technology companies in creating those environments. Tell us a little bit about that.
We hold the customer with the utmost regard and priority. And yes, technically, we can deliver a solution which is totally self-contained within the auto portfolio, but we think the best way to unlock the full potential of what you can do with a customer is through partnerships. We have a piece of the puzzle. It's an important piece of the puzzle, who have other important pieces of the puzzle that are complementary to ours, and how do we build a relationship so that our offerings work together more seamlessly, more out of the box, less time and cost to integrate. And so the demonstration that we have online in the FANUC booth today, I think, is a great example of how a traditional industrial robot technology can be married with a newer AMR technology to give a robot arm some legs and allow it to drive around inside of a machining center, for example, and do work that previously wasn't possible with a machine.
I can tell you there's a buzz around the marriage of your technology with the FANUC technology. And we've had a lot of people come through here and say, hey, did you see that? Did you say that AMR that and a lot of people didn't even know what to call it, but that AMR that was running around with the FANUC robot up in the FANUC booth. So just for what it's worth, brilliant from the marketing standpoint, because you're getting a lot of play on that. And, of course, we're able to tell everybody, yeah, of course. As a matter of fact, their CEO is going to be on the podcast later today, so I know we've had a lot of people anxiously awaiting our discussion today. So let's keep going, talking about applications for OTTO Motors, talking about applications for AMRs. So years ago when I was working in manufacturing and I was actually CEO of the largest contract metal finisher in the United States, and I wanted to really understand product flow in that business. And the way that I did it, whether it was the best way or not, was I got my forklift driver's certification for that particular location, and I worked with the material movers, moving material in and out, because I'm a hands-on kinesthetic learner, and that was my way to learn material flow through that manufacturing operation. Got to know the people that were working as material handlers, running forklifts and so on. Is this technology, our AMRs, going to supplant that technology or the job of a material handler, forklift driver? Will we still have standard forklifts 10, 15 years from now?
That's such an interesting area to explore. So the way that we like to think about it,
Yep.
we think technology will take tasks, not jobs. And if you think about what is the fulfilling, lowest value thing you can pay somebody in your operation to do, it's use their legs.
Sure.
You want to be paying people to use their eyes and their brains and their hands.
Right. Well, and the same is true for them, right? That's where they have the greatest earning power.
Right. So just a quick aside, so our mandate for OTTO Motors is to create safer, more productive, and more fulfilling workplaces
Great.
with autonomous
Yep.
technology. And that more fulfilling aspect is so crucial. People, entering the workforce today, less and less are considering the manual labor part of the workforce.
Right. Part of why we can't find people in
We
manufacturing.
can't find people.
Right.
It's such an incredible problem.
Yep.
We deploy large fleets of autonomous vehicles for our customers, and without exception, the people in the workplace they don't go anywhere.
Right.
They're doing work. They're being employed in other aspects of the operation. We've got a customer who is in the Midwest, and they run approximately 75% capacity. Not because they don't have the orders.
Mm-hmm.
They have more orders than they can handle.
Right.
They run at 75% capacity because they can't find enough people to run the other 25%.
Exactly.
Right? It's a 4-line operation.
Huh.
They run 3 lines.
Yeah.
Right?
No,
And so
exactly.
if you can employ autonomous technology or any automation in the appropriate manner, you can fill that 25% void with automation, increase the output capacity of the facility, secure the jobs for the other 75%, and then actually have a more robust and resilient economy locally versus whoever is making the decision saying, it's not practical for us to run a plant here. We just can't find people. Let's, offshore it to wherever.
And really a more fulfilling job, too, perhaps for that material handler who now has an opportunity to maybe be a technician on material handling equipment, or you're moving to another part of that organization where they're adding value, and likely because they're earning less with their legs and more with their eyes and their brains, a higher paying and more interesting job. So you and I are completely aligned on that. It'll be interesting to watch that evolution take place over the course of time. But I'll give my opinion for the audience, and that is that I think most of those people working in material handling are going to be redeployed in manufacturing and in other really interesting jobs, and we probably will see the vast majority of material handling taking place on a AMR platform in the future. And I think that's an exciting thing, and I think it's a good thing.
So I've spent a bit of time studying technology and innovation in economies and what that does to quality of work. And the work that Henry Ford did to create the assembly line for the Model T transformed the productivity in that workplace.
Right.
So most people with some understanding of automotive history will know about the Model T, right? And within that, some people will have heard of the statement, you can have the car in any color you want as long as it's black.
Yep.
He did that because the cure time on the black was better than anything else, and so
Right.
it helped with the throughput, right?
Yep.
The productivity in that facility also allowed for a couple of things. One, I think he was paying double what the industry wage was at the time for that type of work. And he was able to do that because he could throughput more product in that facility than previously.
Right.
And then the second was, I think he introduced the 40-hour work week.
Mm-hmm.
Prior to that, you had to work 60 hours.
Right.
Right? So you've got people that can work a more sustainable number of hours and are making more money in those hours. So they're still, at the end of the day, taking home the same amount of money, but they've got more time for their family. Right? That's remarkable. Think about what that does to a community or an economy. And that's what we need to be focused on when it comes to the adoption of innovation and technology.
You and I are completely aligned on that. As we looked at automating manufacturing operations, it was all about exactly that. It was about creating a more sustainable business. We never, ever, not once let somebody go because we automated a job. In most cases, you're automating a job, at least in our cases, where it may be more manual, it may be less mentally stimulating. In some cases, we could make a safer workplace through automation. In fact, I would say almost always. And so it did. It improved the quality of lives for the people that were working in the company, and nobody ever lost their job. So it's been fascinating to watch. And you can, Henry Ford is a great corollary, as is what's happened in agriculture all over the last 150 years. Just earlier this week, I saw an article where John Deere is investing several $1 billion in autonomous crop sprayers, as one example. That type of automation has been happening in agriculture for well over a century. People still have jobs; they just are doing different things. So I just think it's a really, 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 really fun time to be alive. And we are continuing to talk to Matt Rendall, the CEO of Clearpath Robotics. Want to change the conversation and talk a little bit now at this point, as we're looking, Matt, in an industrial environment, and we're thinking about who in that industrial environment is going to deploy this technology. So, I buy a new fork truck, it's probably, industrial maintenance perhaps, and then material handling or some version of the, the supply chain team within a manufacturing plant that's going to be responsible for that technology. It's one thing to, buy a fork truck or at least one from Crown and it shows up and somebody learns how to drive it and away you go. A little more technical on the AMR side. So as you're deploying these in a manufacturing industrial distribution environment, who on that team is going to be responsible for making the technology selection and then deploying and maintaining that technology over time?
Mm-hmm. Well, it does vary quite a bit. Typically, you've got, at least in automation mature sectors, you will have a team or teams of people who are responsible for process design, like a process engineering group or a manufacturing engineering group or an industrial engineering group. Sometimes you'll have even an automation team. Typically, historically, that group would be focused on process automation. And then for larger organizations, you would also have a separate group which would be responsible for logistics, production logistics, or material flow, or whatever term you want to apply to it.
Sure.
And they would be generally different because you're spending hundreds of millions of dollars for an automated paint booth, but then in the production logistics side of things, you're figuring out material staging processes. How many machines do you need? How many people do you need? How are you going to be batching and sequencing the materials to the assembly line? Now there's a marriage of those two skill sets, automation and logistics. And so we tend to see more typically we're still interfacing with the folks who are specialists in automation.
Okay.
And we bring to the table some additional industrial engineering, consulting and design capabilities to help round out how do you apply this mindset to material flow. But more and more as the market matures, I think we'll see that production logistics as a discipline inside of a large manufacturing operation will start to bring people with an automation background to help round that out. But in the meantime, we've been working on building out a network nationally of certified systems integrators that have these skill sets available to support going from, hey, I think I'm interested in bringing some automation into my material handling, to a turnkey 24/7 autonomous delivery network operating in some of the world's largest factories.
So in the same sense that, for instance, FANUC may be using an integrator to integrate automation technology into a manufacturing operation. That integrator is going to have a certain skill set, and then there's going to be people at that company that are going to be responsible for implementing it along with it, coming up with the business case, and then maintaining that over time. Sounds like very similar kind of relationship in your case.
Yeah, very much so. We were very fortunate to develop a great relationship with FANUC early on in our journey. Mike was very generous with his team, and they kind of took us under their wing a little bit. And we modeled a lot of our certified systems integrator strategy and program off of the FANUC model. So yeah, I wouldn't say it's similar. I'd say it's very similar.
Yeah, almost identical. The other thing that you've done, maybe on purpose, maybe not, is you have modeled your approach to education after FANUC's approach as well. As somebody who's been around education, you understand what it's like to be in an advanced engineering degree program. You have a degree in mechatronics. As you look to the education world and think about where OTTO Motors belongs in terms of higher education, technical colleges, what programs should be thinking about utilizing this technology to teach their students?
It's definitely the technical colleges are very important to us. If we look at what are the skill sets required to commission a robotic system, go through all the setup, maintain, modify, even develop accessories on top of the platform that we have. There's a pretty well-rounded skill set that we can plug into. So, mechanical, electrical controls, software, all of those programs, and that if we didn't quite talk about it, but mechatronics engineering is the marriage of all of those disciplines into one. So if there's a technical program that has all of those disciplines, I would absolutely recommend it. Machines that come out today are just more intelligent. So if you have a mechanical engineering focus, do some of the options in electrical or controls or software, because the machines that you're going to design down the road later in your career are going to be instrumented with sensing, are going to need the electronics and the programming in order to make that machine smart.
And what an exciting time to be in education, to be a student learning about all these technologies. I wish I had it to go back over and do over again. I wish we had another hour here with Matt Rendall. We're having such a fascinating conversation. But I do want to take time for one last question, a really, really important question for us and for our audience here on the Tech Ed Podcast, Matt. As you think about a high school sophomore, what we call them here in the States anyway, that would be like a second-year student in a secondary education program, 15, 16 years old. If you had one piece of advice for somebody in that age range, what would that piece of advice be?
I think the best thing I can offer, if you think that you're interested in pursuing something in the STEM domain, so science, technology, engineering, or math,
right?
Experiment with it.
There you go.
Get involved, volunteer. First Robotics is an incredible organization
Indeed.
and competition to get involved with.
For sure.
Some of the best engineers that we hire out of school have high school experience with First.
Yep.
That's a good example. It's one that we like to draw upon for the type of students that we like to hire out of school later on in their educational career. But that's just one example.
Right.
There's lots of different ways that you can get that hands-on experience. And regardless if you're going the technical college or university route, hands-on experience is incredibly valuable. Not only to figure out what you love, but also to figure out what you don't.
Equally as
right?
important, yeah.
Knowing what you don't like is so important. There's so many people that wait until they're in the workforce to realize, oh my God, I hate this. Right.
I didn't want to do this. Right.
I think if you can figure out a creative way to do something extracurricular to get hands-on experience, you are going to be having the best return on that energy that you're investing. It's going to arm you with skills that make you attractive in the workplace, but even before that, skills that make you attractive as a candidate to be accepted into the technical college in the first place, and hopefully through that experimentation, you actually find out whatever your equivalent is of the robotics bug, right? I am here today because I did that extracurricular stuff, and I was building robots in my spare time, and I became totally obsessed with it. Right. So that's the single best thing I can recommend to, how do you try and get a leg up while you're in kind of the sophomore stage of your career.
Great advice on experimentation from Matt Rendall, the CEO of Clearpath Robotics, who experimented, found what he loved, and has built an incredible company around that. Matt, thanks so much for taking some time for us on the Tech Ed Podcast.
Thanks, Matt. My pleasure. Happy to help.
Thanks for joining us for this episode of the Tech Ed Podcast. If you haven't already, subscribe, leave a review, and if you like this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.